In a laboratory at Cornell University, we mix together the gases and waters of the primitive Earth, supply some energy, and see if we can make the stuff of life. But what was the early atmosphere made of? Ordinary air? If we start with our present atmosphere, the experiment is a dismal failure. Instead of making proteins and nucleic acids, all we make is smog, a backward step. Why doesn't such an experiment work? Because the air of today contains molecular oxygen. But oxygen is made by plants. It's pretty obvious that there were no plants before the origin of life. We mustn't use oxygen in our experiments because there wasn't any oxygen in the early atmosphere. This is perfectly reasonable because the cosmos is made mostly of hydrogen, which gobbles oxygen up. The Earth's low gravity has allowed most of our original hydrogen gas to trickle away to space. There's almost none left. But 4 billion years ago, our atmosphere was full of hydrogen-rich gases, methane, ammonia, water vapor. These are the gases we should use. Taking great care to ensure the purity of these gases, my colleague, Bishankari, pumps them from their holding flasks. An experiment like this was first performed by Stanley Miller and Harold Urey in the 1950s. The starting gases are now introduced into a large reaction vessel. We could shine ultraviolet light on this mixture, simulating the early sun. But in this experiment, the gases will be sparked, as the primitive atmosphere was by early lightning. After only a few hours, the interior of the reaction vessel becomes streaked with a strange brown pigment, a rich collection of complex organic molecules, including the building blocks of the proteins and the nucleic acids. Under the right conditions, these building blocks assemble themselves into molecules resembling little proteins and little nucleic acids. These nucleic acids can even make identical copies of themselves. In this vessel are the notes of the music of life, although not yet the music itself. Life on Earth